Bismillahirrahmanirrahim. The topic on which I am going to discuss is determination of intensity of sound. Determination of intensity of sound. Determination of intensity of sound. It has been found, it has been proved experimentally that for human ear, loudness L of a sound is directly proportional to loudness L of a sound is directly proportional to the logarithmic of intensity. That is, L is proportional to that is L is proportional to logarithmic of intensity. Logarithmic of intensity. L is proportional to logarithmic of intensity. Removing proportionality, so this implies that L is equal to K log of I. K log of I. Let's suppose this is equation number 1. This is equation number 1. Equation 1 is known as Weber-Fechner law. This equation is known as Weber-Fechner law. Weber-Fechner's law. This equation 1 is known as Weber-Fechner's law. Weber-Fechner's law. And K is constant of proportionality. And K is constant of proportionality. And K is constant of proportionality. If L not represent the loudness of faintest audible sound, loudness of faintest audible sound, faintest audible sound, faintest audible sound, loudness of faintest audible sound, and faintest audible sound of intensity I naught of intensity I naught, then L naught is equal to K log of I naught. Let's say this is equation number 2. Now subtracting equation 2. Now subtracting equation 2 from this equation 1. Subtracting equation 2 from 1. So we get subtracting equation 2 from 1. We have 2 from 1. We have L naught L. Subtracting equation 2 from 1, we have L minus L naught. L minus L naught is equal to K log of I. K log of I minus K log of I naught. Taking K common, so K is equal to log of I minus log of I naught. Log of I minus log of I naught. Now we know that log of m minus log of n is equal to log of m divided by n. So this can also be written as L minus L naught is equal to K. Now applying this over this, so K log of I divided by I naught. The difference between the loudness of the two sound, the loudness of these two sound, L minus L naught. N minus L naught is sound level of the unknown sound and is denoted by beta. So sound intensity level, sound level is equal to beta is equal to k log of I divided by I naught, k divided by I divided by I naught, and the value of this k, the value of this k depends not only, the value of this k depend not only, the value of this k depend not only on the sound, the value of this k not only on the units of I and I naught, but also on the unit of intensity level. If the intensity of an unknown sound is 10 times greater than the intensity of I naught, intensity of this I naught, now then beta is equal to k log of 10 time I naught divided by I naught 10 times divided this, and beta is equal to k log of 10, k log of 1, or k log of 10 is equal to 1, log of 10 is equal to 1. So the difference of the two level is k is equal to 1. The faintest audible sound, that is k is equal to, substituting k is equal to 1. Now putting this k value and 1 and 3 in equation 3, we get, in equation 3 we get, putting the value of k is equal to 1 in equation 1, in equation let's say this is equation 3. In equation 3 we get, in equation 3 we get beta is equal to 1 and 2 log of I divided by I naught, log of I divided by I naught, log of I divided by I naught, log of I divided by I naught. Bin is the unit of, let's say this is equation 4, and this is, then the intensity, sound intensity level is measured in bell. Bell is the unit of intensity which is very large, Generally a smaller unit called decibel is used, which is denoted by dB, which is denoted by dB. 1 decibel is equal to 10 power minus 1 bell, 10 power minus 1 bell. Equation, if the intensity level is measured in decibel, then this equation 4, if the intensity is measured in decibel, then this equation 4, equation 4 can be expressed as, can be written as sound level is equal to sound level is equal to 10 log of I divided by I naught, Let's say this is equation 5, and then sound level is measured in decibel, This equation 5 help us to construct a scale for measuring the level of sound. Such a scale is known as a decibel scale. Such a scale is known as a decibel scale. Such a scale is known as a decibel scale. Decibel scale. Such a scale is known as decibel scale. For better understanding of decibel scale, we calculate the intensity level of different sound. Different sound. Intensity of different sound. For the better, as we know that as the intensity level of faintest audible sound, I is equal to I naught. I is equal to I naught is equal to 10 power minus 12 watt per meter square. 12 watt per meter square. Therefore, intensity level beta is equal to 10 log of 10 log of 10 log of log of 10 log of I naught divided by I naught. I naught divided by I naught is equal to 10 log of 1. 10 log of 1 is equal to 10 into 0. 10 into 0 because log of 1 is equal to 0. So is equal to 0 decibel. 0 decibel. The intensity level for faintest audible sound is equal to 0 decibel. 0 decibel. Similarly, intensity of Russell Lewis I is equal to 10 power minus 11 watt per meter square. Therefore, intensity level beta is equal to 10 log of I divided by I naught is equal to 10 log of 10 power minus 11 divided by 10 power minus 12 is equal to 10 into log of 10 power minus 11 plus 12 is equal to 10 log of 1 and log of 1 10 log of 10 log of 10 log of 10 and log of 10 is equal to 1. So 10 into 1 is equal to 10 decibel. 10 decibel. So the intensity of faintest audible sound is 10 power minus 12 or I naught 10 power minus 12 watt per meter square, and its intensity level is 0 decibel, and the intensity level of the normal breathing or Russell of Lewis or normal breathing is 10 power minus 11 watt per meter square is equal to 10 decibel. 10 decibel. For whispering, I is equal to 10 power minus 10 watt per meter square. 10 power minus 10 watt 10 power or average whisper is 10 power minus 10 watt per meter square. So its intensity level is 20 decibel. 20 decibel. Thanks.